thousand, turn us to thousands.
Now I'm going to explain about my project Mirror Jarvis.
Hi, the time is 6:33 p.m. Have a wonderful day. Sorry, news playback isn't supported on this device yet.
So this is Jarvis. Now you can see the time updates, weather updates. I have used auto turn off screen. So by this method, I can turn off the screen once whenever there is no person in front of this mirror. Here you can see news updates. And here I have used WhatsApp notification, not only WhatsApp, like email messages, all the notification which are coming in mobile phone can be synced with this device using push bullet module. Here you can see the history which was happened in the current date, like in 1544 Italian war was happened, it seems. So like this we can have the historical updates here. And I have also used a graphical module for weather updates, like it will forecast the weather for the next 4 days, humidity details, pressure, etc. Then you can see the stock market values, like I have currently shown Apple, Google and Tesla stock market along with the graph. Here you can see the devices which are connected to this network, like GitHub. Actually it is just syncing with my GitHub account, and laptop, mobile, all those are devices which are currently connected with this mirror. So currently I have turned off all those devices, so it is not highlighted. Then I have also set an alarm at 11-12 p.m. every Monday. Like on Monday I will an alarm will be turned on for my team meeting. Here you can see news updates from New York Times. You can also stream the news updates or YouTube videos from any of your devices to Jarvis. Now you are seeing the news within the class itself. Like we can see the news updates, or we can groom ourselves by watching our mirror instead of having separate devices. These are the photos which are updated from my Google Photos.
I'm Yazh and I'm from Electronic and Instrumentation Department. We have developed a home automation model which uses MQTT broker and helps to connect the Internet of Things devices. Now I'm going to explain how our model is different from the existing one. Usually Internet of Things uses third-party APIs for their communication, which requires continuous connectivity. In this model, we're using a Raspberry Pi as a server which would store the data without the internet connection. The data would be synced with the device once the internet connectivity is back.
Now I'm going to open my Arduino IDE for code upload. I have already done it, so I'm just opening the serial terminal for your output reference. Yeah, now you can see the data are being generated, and this is within the terminal. Actually, this data are obtained via the wire which was connected with the node MCU. So the main difference between our project and the existing one is, like, we didn't use any third-party APIs like ThinkSpeak or IFTTT or Blink application, which provides a very high latency for connecting the IoT device. Like usually it will take around 7 seconds, I guess, for data transfer. Like what we developed is we created our own server for IoT devices. So we are implementing edge computing here. Graffana is an UI which helps us to demonstrate the working of the sensors, or we can see the live fetch of every data. Like I can set for every 30 seconds, and the data can be viewed afterwards, like after a week or after a month. Those data can be viewed easily. It can be viewed like by selecting certain options, you can fetch all those data. So there is no need of writing any query or any logics behind this. Like if you select this month or this week, so that you can get all those data, like you can apply time range. So you might ask like where these data are stored, right? So I have used MySQL for storing the data. So here you can see like this is the terminal of from Raspberry Pi. So I am going to fetch all those data like select. Yeah, so it just throws all those data which were obtained. So these are the raw data which were stored in MySQL database. These data are getting pushed to Grafana and MQTT broker. Every manufacturers are bringing home automation concepts nowadays, like Philips or Xiaomi. Everyone is bringing, like they are trying to sell their own products instead of selling a switch. So instead of spending 500 rupees for buying an IoT bulb, instead we can spend rupees of 500 for getting our entire switchboard to be automated. Like we can automate our entire switchboard with 500 rupees instead of buying a single bulb. I've used a relay and I have connected with ESP8266 Wi-Fi module. Then I have used two bulbs for demo purpose. So there are four different ways you can connect to. You can use your IoT devices. Like you can turn on manually. You can use Google Assistant. You can use Node-RED dashboard, or you can use Google Home app for connecting. Now I'm going to use Google Assistant for turning off the night lamp. Turn off night lamp.
Sure.
Turn off light 1.
Okay.
So even though we are sophisticated with internet, there might be some situations where you cannot access your internet connection. So we have also used a manual switch for controlling the device. I'm using a Node-RED dashboard. So I'm just turning on the bulb 1, and I'm turning on the night lamp, so it's getting turned on. I'm going to turn on the night lamp with the Google Home. Yeah, now I'm going to turn on the light one with the Google Home. So there are four different ways like you can connect your IoT devices. We can also use Remote It, an application which assigns a dynamic IP for our Raspberry Pi so that we can use the access remotely.